Unite beyond boundaries. Innovate together. Joe's PANKRATION 2024. No border.
Hello everyone, and good evening to everyone in Japan. NTT DOCOMO, Japanese largest mobile network operator, has built a cell phone base station data processing infrastructure for 85 million users on AWS called Minaden. We will discuss the details of Minaden. Before our presentation, let me start by my introducing. My name is Ryo Ozawa. I'm an AWS Junior Champions and all certifications engineers. I'm working at NTT DOCOMO as a data engineer and cloud engineer. I'm interested in parallel distributed processing, ETL processing, and streaming processing. I'm not good at speaking English, but I will do by my best. As you can see on the slide, today's presentation will cover 5 main points. First, let me explain what Minaden is. Minaden converts cell phone base station data across Japan into variable data in real time. The number of users is 85 million. The number of base stations is 60,000. Amount of data per day is 200 terabytes. 3.5 minutes from Minaden input to output. Data processed by Minaden are used to network analysis, network quality improvement, and fault handling. Data between base station and cell phone. It's called control plane data. Next, we will explain the AWS architecture of Minaden. Minaden is a microservices architecture configuration. It consists of 3 main functions. Data that requires real-time performance is sent to Kinesis data streams. Data that is not required to be real-time is sent to S3 and processed by Athena for analysis. This is Minaden's AWS architecture. Let's explain details of function 1 called receiver. This function is called receiver. Receive 200 terabyte per day from 4G cell phone base station. When data is received from the base station, it's in binary format. So we have to convert to human decodable format for analysis and other processes. And we have Kinesis for each type of data. So we have to filter these data. And we have hundreds of EC2s. So we have to adjust auto-scaling based on CPU, memory usage, and amount of data. Data processed by receiver are sent to function 2 via Kinesis. Let's explain details of function 2. This function tracks dynamically changing network data to allow analysis of network quality for each user. Network equipment sends network data corresponding to cell phone base station data processed by function 1. These data are stored in elastic cache for Redis because it's read and written frequently. Then tracks dynamically changing network data corresponding to cell phone base station data processed by function 1. Then combine cell phone base station data and network data. This process allows us to analyze network quality on a per user basis. This data is sent to function 3 via Kinesis. Advanced analysis is possible by using machine learning. Let's explain details of function 3. This function allows us to advanced network analysis. We have developed over 300 machine learning models on Amazon SageMaker. Our code pipeline environment includes step functions, SageMaker processing, and code build. Using the SageMaker processing is useful to data preprocessing. Using the preprocessed data, the model is trained and a container image with the trained model is creating using code build. API server is updated automatically. Client server receives processed data by function 2 and requests API server. API server responds with the results inferred by the machine learning model. Send the response data to other systems and data warehouse via Kinesis. It enables advanced network analysis. The three functions we have discussed so far require real-time processing. Next, I will discuss the functionality that does not require real-time processing. We have ETL function using Athena, used for ETL processing that does not require real-time performance, and used for batch processing in units of 10 minutes to 1 hour. The ETL function uses data processed by function 1 to 3. And both this data and related information for analysis purposes are stored in S3. Using these data, simple join operations are performed in Athena. AWS provide other ETL services like Glue, Amazon Managed Service for Apache Flink, and EMR. Athena is lower cost than these services and simple to use. ETL processes are enhanced in response to analytics and analysis requests. Next is issues with AWS costs. Minaden system is large system size and high cost. Due to a lack of cost monitoring and awareness, unnecessary costs were incurred. So we have to promote cost reduction and cost awareness. Our cost reduction efforts include purchasing savings plans and migrating to Graviton EC2 instances. We purchased EC2 savings plans not reserved instances. Ri has a higher discount rate, but the instance family is fixed. It is not flexible, but savings plans can be switched to low-cost type and can be applied to Lambda and Fargate. Good opportunity for architecture optimization, and SP is very flexible. Next is migrated to Graviton. Our environment improved CPU and memory performance, and migrated hundreds of EC2s, reducing significantly reduced AWS costs. Next is Slack application. If you want to check AWS cost, you will probably use AWS Cost Explorer, but this is a bit cumbersome. So we developed an application on Slack to easily check AWS costs. For example, post a message to Slack like, tell me the cost of function 2 for 5 days. Specify function and duration. Then display costs and graphs for each service. This made it easier to check AWS costs. And this application can automatic detection of cost spikes, identifications and notification of functions and AWS services. This prevents unnecessary AWS costs. Next is stop unnecessary AWS resources and promote cost awareness. We have monthly meeting to monitor AWS cost. Just checking AWS Cost Explorer or the Slack application might not provide the details of AWS costs. Not everyone uses the Slack application either. So we have a meeting where everyone checks cost and has an opportunity to identify cost issues. This helped find unnecessary resources, such as EBS volumes, and resulted in significant cost savings by deleting them. As a result, promoting our cost awareness. We also developed an application to shut down EC2 in the validation environment at night. This prevents unnecessary AWS costs. Next is Minaden's future. Now we can only process 4G cell phone base station data. The cost of Kinesis data streams and Kinesis file force is proportional to the amount of data. It's too high for us. This is problem. Future, we have to process 5G cell phone base station data for analysis.
残り1分です。
We want to maintain simplicity and scalability while realizing cost-effective streaming processing using S3, SNS, and SQS. This approach is currently under validation. This architecture's performance is nearly the same as it was with Kinesis. Here is a summary of my presentation. This concludes my presentation. Thank you very much for listening.